so this is CRT Repair. How many people have ever worked on a CRT monitor or television before? Okay, most of you. But about half of you haven't. How many people recognize what this is? It's a TV. They didn't used to be flat. So, I mean, I'm using TVs to demonstrate because they're simpler and easier to see inside of. But the same kind of principles apply to any CRT monitor, and computer, VGA, terminals, whatever. Basic principles of operation. There's an electron gun back in the picture tube that fires a beam of electrons toward the face of the screen. I mean, left to its own device, it would just be a dot in the center, which isn't really all that useful. So there's this magnetic coil. This coil is called a yoke, and it's two separate coils. I've got a separate one here. Two separate coils. There's the horizontal winding, which is on the inside here, and the vertical winding, which is on the outside. And these have signals applied to them that create magnetic fields that bend that single point, that single beam of electrons, so that it draws it across the screen, back and down, and keeps going down the screen, refreshing it. The whole display gets redrawn 60 times a second, and the persistence of vision of the phosphorus, the glowing, and remaining glowing kind of gives that picture. The difference between color and black and white in terms of like what's in the gun structure is that the color tube has 3 separate cathodes that can emit the electrons, and the monochrome tube only has 1. Beyond that, both the types of displays are pretty similar. Now the magnetism aspect of how these work is where you have magnetic interference and things. Like, so this is just a regular TV, but if I turn it on its side, all the colors get messed up. Whoa. Because the Earth's magnetic field interferes with the operation of the set. So like now it's reversed, it's different, or it's turned on its side compared to where it was before. Put it back up, the colors go back to normal. So if you've ever seen a display with kind of messed up colors that's kind of screwed up, and then especially if you come back a couple days later and it looks okay. Every color TV and monitor has a degaussing coil, which is a magnetic coil that is has this coil around the edge of the tube. Just a coil of magnet wire, and when you turn the set on, there's a thermistor here, and that coil is connected in series with this thermistor, so that to the AC line directly. So you turn the TV on, you get that kind of boom noise, and that's this thing being very low resistance, send the AC through that coil, and as this warms up, it increases in resistance, and then the AC tapers off, and then the coil becomes inactive. So if you have a TV where that isn't working, thermistors fail, cracked solder joint, something like that, then it'll never degauss, and it'll never fix itself when you move it. And the reason that's in there is because every time you move the TV from room to room, it has to be degaussed. Really, really early color sets in the first couple of years, they didn't do that. Like the TV guy actually come to your house and do the set. And get rid of that residual magnetic field on the screen. So anyway, what's happening here, why this is such a big deal, is inside, right behind the glass in one of these tubes, in a color tube only, there's a metal shadow mask. It's like a mesh of Trinitrons use the mesh of wire in the screen door. This is more of a perforated sheet of metal with tiny holes in it that helps prevent the color beams from hitting the long phosphorescent nodes. But now that this piece of metal will get magnetized, just moving through the Earth's magnetic field. It's a very tiny field, but it's there. So now that I've moved it, it's screwed up. But if I can then clear out that magnetic field. This is just basically the same kind of coil that's in there as a handheld degaussing coil. And so now the colors are all screwed up. Cool. But then this is an AC magnetic field. And clear that field off of the residual field off of that shadow mask. But then now that I've degaussed it in this position, if I turn it back right side up, colors are all screwed up. This was a kind of a fun practical, remember old computer monitors used to have a button for degauss, that's what that was. In case, because they were on a swivel stand, so if you were to swivel the monitor all the way around, it's possible that you'd cross enough field lines where it would screw up the picture. So you'd be able to manually degauss a monitor like that. So what you do is if your coworker goes to have a coffee, you turn his monitor on its side, degauss it, put it back up, and then the colors are all screwed up. And if he hits the degauss button, it's not going to work because the thermistor is still hot from the time you just did it. So it's got to wait like 10 minutes for that thing to cool down. But of course, this is a set analog coil, so I can just do this as much as I want. And the trick to doing degauss is you have to start far away and then move it away before you turn the coil off. There's going to be a tapering, like a tapering down, reducing magnetic field. If I just do this, I'm going to impart that magnetic field on the tube. I want to clear it off. So if you ever have a monitor where you've got like this weird wash of color, it's possible it's like next to a speaker. For instance, what I always say, keep speakers away from TVs because the magnets in the speaker can impart magnetic field on here, or that's why you can't play with a magnet on the TV. It looks all cool, but then they leave that magnetic field behind. And you got to be careful because if you put too much of a magnetic field on, you're not going to be able to erase it. It'll kind of be permanent. Or if it's a big enough magnet, you actually bend that shadow mask. The same thing can happen if the tube is dropped and dislodged inside. But that's kind of the very basics. I only have an hour to go through this stuff. So, very basics of how that kind of system works. The other most famous thing about CRTs is, of course, the high voltage issue. How many people are afraid of taking a TV apart? Yeah. that is the thing that everybody's most afraid of. Oh, you can never open the TV. It says back here, risk of electric shock, do not open. Well, I do not believe in warning labels, so I'm just going to ignore that. And I'm going to open it. Of course, I prepared this earlier and took most of the screws out, so this is faster. And then I say about a TV is that there's no shielding, it's really easy to see all this stuff. So, okay, this TV was just turned on, so everybody says, oh, you gotta wait like a week before you get to mess with everything. So the reason for the concern is that the CRT itself actually acts as a great big capacitor. The high voltage, the accelerating voltage of a TV like this is something like 25,000 volts. And this CRT is actually a big capacitor. There's a coating on the outside called aqueduct, or just DAG. I'm not quite sure the correct pronunciation, but DAG brown is what this is called. And then this kind of attaches to trash chassis. So I can touch this all I want, even when the TV's on.
All the gray there is conductive.
Yeah, it's conductive. It's graphite. It's graphite conductive coating. And then on the inside of the tube, you can see it through the glass. This red is another coating that's conductive on the inside. And then the glass itself forms a capacitor. The plate, the insulator, and the capacitor. So when you want to take this apart, if I disconnect this wire right now, it might still be charged. This might have a bleeder in it. I don't know. We're going to find out. To discharge this capacitor, make it safe to disconnect this wire, I'm connecting. This is just a regular screwdriver, nothing special. This is a clip lead, carbon frame something. I'm connecting the other end, one end of it to DAG ground, which would be this metal mounting here of the tube, this frame of the tube. It's connected to this springy strap. Where is it on this one? It's down here. It's hard to see. There's this little metal strap that contacts the bell of the tube and makes contact with that outer coating. So if I short out the capacitor formed by the picture tube, yeah, see, it doesn't have to charge, because I think this says new enough, it might actually have a bleeder in it. Let's see if I can get it to say.
Hey Ian,
Yeah.
what's the reason for the spring? I never understood the spring.
The spring is just to keep that in contact, like tight contact with that coating. On like a Macintosh compact Mac, you'll see it's just a metal bracket with a springy piece of metal contact that just touches one corner of it. All that needs to do is just make some kind of electrical contact, but because there's no terminal or screw or anything, you need something to just kind of grab it.
Okay.
So yeah, the spring with a strap on it works is cheap and easy. I'll turn this back on.
You can also see sometimes like that,
Oh, I see.
it's just a plastic television, so the whole front is non-conductive, but sometimes the tube will be bolted to the chassis, and it can ground through that little strap on the little
Yeah,
thing.
to the chassis itself. Generally they try to. Of course, the ears on most tubes are supposed to be connected to that already, but might not be. Okay, so that's on right now. So unplug it. And then, yeah, don't ever discharge it while it's on. It's a bad idea. I got a little click of it. Yeah, it's supposed to have a bleeder resistor. Some flybacks will have a bleeder resistor to kind of bring down that charge to make it safer to work on. But anyway, it's discharged now, so I can disconnect this.
One question regarding this safety. So the handle of the screwdriver is usually rated for like 500 volts or 1 kilovolt, and you said this can be like 25 kilovolts.
It's
So
really low current though, really low.
So it's not going to do anything.
Yeah, this is a Harbor Freight screwdriver. It's rated for $1. You know, there's nothing special about any of this stuff. Just the fact that this is plastic is more than enough to protect me.
Okay.
You think about it, when you shuffle your feet on carpet and generate that static charge and touch a light switch cover or doorknob or something, you get that zap. I mean, that's thousands of volts. So that doesn't hurt you. This is thousands of volts, real low current, real low capacity. If you do touch this, it will be significant. It will hurt. You'll jerk your arm back. You're actually in more danger of jerking your arm back and slamming it into something and cutting your wrist on the metal, or like in an arcade machine. That's a real big problem. If you were to be inside, like in the game, and zap yourself and bang your head on the cabinet, or that happening.
It might stop your heart in that scenario too.
It shouldn't. I shouldn't stop your heart. Now I'm not a medical professional, but it shouldn't stop your heart. It shouldn't be enough for that.
Yeah.
It'll hurt like hell. You'll wish you hadn't done that. Your arm will feel kind of tingly for a half hour or so, be numb for a bit, but it's not gonna. It shouldn't kill you. It shouldn't.
So you're speaking from experience.
Yeah, I mean, I have been zapped once or twice. I try to be careful, but anytime you disconnect this wire, you should discharge it like this. It doesn't matter if the TV's been sitting off for 20 years. Just do yourself a peace of mind. Get in the habit. Every time you unhook this, discharge it. It takes 30 seconds to do, because sooner or later you're going to be working on something. You're going to be tired. You think, oh, I didn't get any high voltage this time. It didn't work. And then you go to unhook it and zap yourself. And, oh, I did get high voltage.
So is there any other voltages on the circuit board or anything that?
Yeah.
But before you go to that, the tube can also, if it's been running a lot, can recharge itself a little bit, right?
Yes, it can. After it sits for a while, especially big tubes, I think it's called like electron absorption or something to do with physics. The tube can recharge itself. You can then, after the thing's been discharged, unhooked, sitting for a few minutes, you can touch this and get a little bit of a zap. It'll be like a, oh, that's something. It's like barely, it's like a heavy duty like doorknob.
Yeah.
It's nothing to be afraid of, but it will startle you. And if you have, say, for instance, I don't know, taken the chassis out of a 25-inch arcade monitor to do something, and then you go pick the monitor frame up with the tube in it and touch it while you're lifting it. And
Which you usually do with your forearm at that
yeah,
point.
you don't want to zap yourself. You don't want to startle yourself and drop it on your foot or something. Where was I going with this?
The voltages, any other voltages on the?
Oh, yeah. So the only other things you might want to be mindful of is things like filter capacitors, especially if the D+ supply has failed. So this is just the chassis out of this whole TV here. This is another interesting thing to touch on. This is a hot chassis television. It only ever had an antenna input. It has no composite video. This is not electric. This is all electrically connected to the AC line. There's no isolation here. So the user's insulated because the buttons are plastic. You're not going to be able to touch it. All this is AC comes in, rectifier, filter. This is just next to capacitor. Rectifier. This is the bulk filter capacitor for the B+. This could theoretically still stay charged, especially if the B+ fuse has blown because some fault. Then this might still be charged. So you kind of want to just be.
Okay, so electrolytic caps or whatever.
Yeah, and you can just short it out on the back of the board with a screwdriver, or like what I'll do is I have a cheap pair of needle nose pliers. You just open it to the width of the capacitor and touch it to the terminals and discharge it. You'll chew the end of the pliers up, but use cheap pliers. But this TV is hot know you've it's becoming popular with RGB mod TVs to get direct RGB into a TV set. If the TV doesn't already have a composite video input, do not attempt to modify it. You will fry something. As soon as you plug in your game console, it might be okay because the game console runs on a power brick that's isolated, but now the game console is hot. So it's, yeah, you gotta be very careful if you start modifying a TV. This TV is newer. This is would be isolating chassis. You can tell by looking at it. So this is just rectifier, filter cap, regulator. There's no power supply to speak of. Just a bunch of resistors and a regulator. This, however, if I can get the chassis out a little bit. It's probably got a catch on it. I should have taken this one apart ahead of time instead of tied in. But you can kind of see this looks more like a switching power supply, computer power supply side, because you've got this switching transformer, chopper transistors. This is cold chassis, so it's got a little hot section where the power supply is, but you'll even see there's usually a line denoting where the hot and the cold sections of the chassis are. So like this TV could be RGB modded safely. I'm trying to remember where I was going with this. Oh, forgive me for being a little bit scattered. It's been a busy couple of days. Okay, so safety, yeah, discharge the tube before you unhook it. Don't ever disconnect this without discharging it. Don't touch this while it's on. A lot of people think that this suction cup is some significance. This is just to keep dust and fingers and drop pennies through the vents out of the high voltage. Really old TVs didn't even have the boot. It was just a clip. Just a bare. This rubber is the boot, a protective covering. So it doesn't actually need to be suction cups to anything. There's no grease that needs to be here. There's no sealant. It's just to keep dirt out of it. But this clip, it's kind of the top of a Christmas tree ornament. It's just two little wires that hook. This is actually a hole in the tube. There's like a metal button cup molded into the glass, and that connects to the accelerating anode inside the tube. There's like this cup that kind of well, it's actually from here that kind of makes contact with that inner coating. So how does the basics of this thing? How does why the high voltage? So you have there's a filament in here that gets hot, heats up the cathode. The cathodes then emit electrons. The signal's applied to the cathode, and that's how you modulate that beam of electrons. So it will just kind of be this flashing little beam. This, of course, bends the beam around. But in order to accelerate those electrons, again, physics, there's the high voltage. There's an accelerating anode here. There's actually a couple of anodes. There's a focusing anode, which adjusts adjusts the voltage that's around 1,000 volts or so. That adjusts the kind of like the point at which the beam gets focused.
When you adjust the focus control, you're adjusting the voltage on that, right?
Yeah. Then there's the accelerating anode, which this is actually technically called the second anode. This is what accelerates the electrons toward the screen. So if the high voltage sags, sometimes you'll get what's like blooming, where it'll kind of like the picture actually is a little bigger because it's not being accelerated as much. So I'm gonna plug this back in. It's talking about focus voltage. That is so the high voltage comes from. Who here knows how a switching power supply works? Roughly. The basics of a switching power supply is kind of how a TV set works for monitor. The horizontal drive section is what powers, which is in this case it's a 15.75 kilohertz horizontal signal in a TV and any composite monitor. In an MDA is like 18 kilohertz, VGA is 31.5. But that horizontal signal, that horizontal frequency, is applied to the primary of the flyback transformer, which is this transformer that creates the high voltage. And this is basically a switching transformer. It's a high frequency transformer. You apply that horizontal frequency to the primary, and then this creates a bunch of other voltages. It creates the high voltage. There's also a diode in here. Embedded in here, there's a solid state diode. Really old TVs, really old black and white TVs will have like a selenium stick diode in line. Going back even further, it's actually a vacuum tube, but that's going back into the 60s. Because this is DC, it is creating DC. You've got high frequency AC, a diode, high frequency AC filter capacitor. high frequency DC, pulse DC because of the diode, filter capacitor from the tube itself. If the diode fails, CJ experienced something like this, the diode shorts out, the thing just draws way too much current and shuts down.
Twice.
Yeah. It's really rare that the diode fails. He had a very unusual set. But anyway, this flyback transformer also contains a voltage divider. That's this kind of block on the back here with these knobs on it. This said there's focus and screen. Screen is the G2 voltage for the cathodes. Just basically the overall picture brightness. So you can turn that up and get the thing over bright. Then this is just the focusing voltage. These are just knobs. These are potentiometers. This is the high voltage transformer, but you can turn these with your fingers because they're plastic knobs on a plastic transformer. But you got to watch out if there's any cracks in the casing or you're having issues with this. Like be kind of careful with that. Especially Wells Gardner K7000 arcade monitors develop these cracks in the flyback, and you actually could get zapped because it's arcing. Sometimes one of the failures would be high voltage breakdown of the transformer. It will start to arc and zap sometimes, either internally or externally if there's a crack in it. You can seal a crack sometimes with like high corona dope and paint on a couple layers, and you can insulate it enough where it won't arc. But sometimes the arcing is internal, deep in the flyback, you're not going to fix that. Let's see. Again, apologies for the kind of jumping all over the place. I'm not exactly a teacher. I didn't exactly rehearse this or anything.
And so Ian, when you say horizontal, what you mean, like that's every time the beam goes across the screen, right?
Right. That's there's the vertical pulse, which in a TV is 60 hertz. So you've got basically picture a sine wave amp being amplified, a 60 hertz sine wave being amplified, and that's how you drive the beam from the bottom of the tube back up to the top. And then the horizontal is the 15.75 kilohertz. So you're traversing the horizontal part of the TV much faster, which is why if you measure the resistance of a yoke like this, the horizontal line will be real low resistance, something like 2-3 ohms, and the vertical will be higher, like 20 ohms, because the vertical is much slower coil. It needs to not saturate. Then it goes back to how transformers can saturate if you apply something too long. We'll get back to that one. Okay, let me turn my little tester back on. That's on to the right channel. Disadvantage to using a TV. Oh, you also got to connect the other end of the wire. Okay, so let me get process pattern. So this will show, this particular set, there are the knobs are reset, so I can't use my fingers. If I mess with this focus knob, I can make it all blurry. You can kind of see the corner here a little better. And this is just adjusting that voltage. So if you have a TV or a monitor that is blurry, you might be able to adjust the focus control on the flyback dial. And sometimes has the tube ages, so that inside the tube, perhaps bring it up. It's got a gun assembly. If you're interested, I actually have a gun assembly removed from a jump tube. You can see how the elements fit. But the actual cathode, the end of it, as the material wears away, like that point kind of gets bigger, spot size increases. So as the tube ages, the picture gets dimmer and blurrier. And you can compensate for that a little bit by adjusting these controls and changing the focus voltage to dial it in, make it bright, make it sharper, and adjusting the screen control here so I can make it way too bright. And then you can adjust that so the blacks are actually black. Sometimes you'll see a set, especially Sony VGA, Sony Trinitron monitors, VGA monitors, like the high-end ones from the 90s and 2000s. You'll see them where it just looks like that. And there's no way to adjust that because there's no knobs on the flyback on the Sony. The way that's adjusted on those particular monitors, there's a serial port in the back, and you run special software on the computer with a cable to change the values in software. some reason, whatever stuff that electronic control stuff they use just drifts over time. It's like half of them I see need that. Another thing you'll sometimes have is a TV or a monitor that the longer it's on, the brighter it gets. It will slowly get brighter and brighter and brighter, or it'll be way too bright and it'll slowly get dimmer and dimmer. So you have to like, let it warm up before it's good, or if you adjust it when it's first cold and then you let it warm up for 10 more minutes, it gets really bad. That's usually this voltage divider. This is a resistor voltage divider. This is breaking down in the flyback and it's failing, either from cracks or moisture ingress. Again, real common on K7000 arcade monitors. So let's see. That's kind of the basics of how it works, how to adjust it a little bit. Really common failure modes, just kind of off the top of my head, are things like, have you ever had a TV or monitor that works, but if you hit it, like, or it fails, like it collapses, like in the horizontal line, for instance, then you hit it and it pops back. The yoke here, there's a fair amount of current that goes through here, and fairly high voltages, and there's just this 4-pin connector that plugs into the board. So a really common failure is that this connector gets kind of crudted up, or more likely the solder joints on the board that are connector soldered to the board crack. So simply like resoldering those joints will fix a problem like that, where the picture collapses, you hit it, it comes back. Other common failures are like the vertical, where you have the top is folded over and kind of crumpled up. That's a bad capacitor in the vertical circuit. Now, I'll talk to you last about the schematics. Like, how do I get schematics for a given set? Like, how would I get schematics for this? Like, this is actually easy because I could get the Sam's Photopack schematic for this. But let's say you've got a monitor you don't have the schematics for, can't find them, and you've got a problem like the picture's folded over or curled up like that. You can kind of just look at the circuit board. Like, I obviously don't have the schematics for this, but I can just look at this and see, okay, that's the vertical output chip right there. And so a problem with the vertical is going to be one of these capacitors that's connecting the vertical. Not only do I know it's the vertical, how it looks, but this is the connector. This actually has two connectors for the yoke. This is the connector for the vertical. Also, because the horizontal is so tightly coupled to the high voltage generation, the horizontal yoke connector is over here right by the flyback, because the horizontal yoke is in series with the primary of the flyback transformer. So you can kind of look at the board and trace the circuit out and kind of get an idea for what's where. Another trick, I don't know if it rings true with this TV, so that says C55. So a lot of times all the numbers on the board will have, okay, this one doesn't do that, of course. But frequently, a lot of TVs or monitors will say, how like this is the vertical chip is Q or IC 301. And then all the other vertical parts will begin with 3. So the C302, R301. So all the parts of the vertical circuit will begin with 3. Or like the flyback is T501. So then you see, okay, the horizontal output transistor that drives that flyback primary is Q501. And you can kind of guess, okay, all the horizontal parts have 5. So if you have a horizontal problem, that's just kind of how to sort of trace a circuit without the schematics, without actually knowing how it all goes together. You can kind of figure it out. There's also but only so many ways to build a monitor. They all work the same way. So once you kind of understand how one of them works, they all kind of make sense. Some caveats though. So like, okay, so this up on the screen I have the schematics. This is a Sanyo EZ20 or 20EZ arcade monitor. This is what games like Donkey Kong used. Arcade monitors are hot chassis. So if you're ever working on an arcade monitor, be wary of that. Arcade machines have a isolation transformer, 1-to-1 isolation transformer in the bottom of the cabinet. So don't ever plug an arcade monitor into the wall directly and hook it up to stuff. So always use an isolation transformer for an arcade monitor, unless it's specifically one later ones that doesn't need one. But anyway, this is a hot chassis monitor, but...
And just to put a pin in that, like, when you say hot chassis, that means like the neutral of the chassis might be at 120 volts.
Correct. Yeah, ground is relative, and that might not actually be ground. And so you'll create this situation where you've got 120 volt differential between your video input and your computer, which leads to burning transistors and frying traces and all kinds of bad things. smoke and bad smell. The reason they can get away with it is because like on this TV, this is an isolating capacitively coupled isolating thing just for the RF, the antenna input. So this is electrically isolated from this, and this is the plastic rectangle. The whole cabinet's made out of plastic, so it's completely isolated from the user. But you're directly connecting stuff into it, which is what they did with an arcade monitor, right? It's physically in a wooden box. They can isolate it, run it from its own transformer. But what I was wanting to try to find in this is the horizontal circuit. So like a TV set, like with no picture, with no input, a TV set displays snow or like blue or something. Yeah, see, I've got snow here, and see how whenever you've got a TV like this, see how like see how the little manual things, the volume, display. I turn it on and off too fast. The volume display is all kind of screwed up whenever it's displaying static because there's no horizontal sync signal. If you can hear the real high frequencies, you can hear that a TV displaying static sounds different than a TV displaying an image. Because the TV has a local oscillator to generate the high voltage. Because that horizontal signal is important for the flyback to create high voltage. It needs to be there all the time, otherwise the TV wouldn't display a picture unless you've got wouldn't do anything unless you have a signal. So it's a local oscillator, but it doesn't necessarily run exactly on frequency. So things like the Apple II composite monitor will kind of whine a little bit more when there's no picture. The cheaper monitors especially more. A TV will. And then whatever incoming signal gets then mixed with, gets matched to that frequency. So as soon as you get a signal, you get that stable horizontal sync, then it quiets down. That transformer was designed to operate exactly at that frequency and really nothing else. So of course, arcade monitors are built like that, TVs, anything that takes composite video basically is going to be built like that. But when you start dealing with things like MDA monitors, that's a monochrome monitor from an IBM PC clone. It's like the IBM 5151, any generic MDA monitor, monitor that's built into most computer terminals, and like a K-Pro, for instance, has no local oscillator. It will not generate high voltage, it won't do anything unless it has a signal from the computer. So I've seen people will get like 5151, they'll plug it in and turn it in, but it doesn't do anything. And it won't do anything because there is no horizontal signal. You're not going to be able to get any kind of a picture. You can't turn the brightness up and see anything because you've got no horizontal signal, which means you have no high voltage. Other things that the flyback generates more voltage. In most sets, the flyback generates more voltages than just the high voltage. It generates the 12 volts and the other signals or voltages that powers the other logic on the set. It also generates on almost every TV and monitor. It also generates the filament voltage. So the filament won't glow if you're not getting any high voltage, which is people think they see all this filament glow. That's the problem. No, that was a symptom of the fact you have no high voltage, you have no filament. Granted, a lot of 12 volt monitors, like the ones in terminals, the filament is just run directly off the DC input. But if it's not, it's created by the flyback, and you can actually even see. So this flyback, you can see coming off of here is this is the focus voltage. It's got its own separate connector that's sealed up. That's fairly high voltage. It's about 1,000 volts or so, and it's got its own separate pin that's in the key of sealed off on this key. So if you have a monitor that display gets fuzzy and kind of doesn't look right, you can hit it and it comes back. It could be that this is just corroded because of the high voltage, especially with moisture in there. This pin can corrode, so you can kind of take this apart and clean in there. Okay, that's the focus voltage. This is ground. And then these signals here are for like the cathode. So you have this is the screen voltage coming off the base of the flyback. That's that screen pot. This is a few hundred volts, and that's how that voltage gets up there. It's separate. And then in here is going to be filament and cathode and the actual video signals and stuff. But again, you can just kind of tell all that just by looking at the chassis, what you know what to So yeah, other common failures of if you're not getting any picture at all, you're not getting any high voltage, you can usually either hear it or feel it on the screen, you feel the static, you turn it off and you hear that of the high voltage collapsing and the static kind of crackling. If you're not getting any of that, which that means something is either like power circuit isn't working, the horizontal circuit isn't working. So in here we have, where's the flyback? I should have actually, planned this better. So here's the prime. This is the flyback transformer, and you can see where here's the primary, flyback primary, and that is driven off of this. This is the pre-drive. This is the actual driver transistor. This is the horizontal output transistor. This is basically it's like the chopper transistor in a switching power supply. And this is what actually drives the flyback primary and the horizontal deflection yoke, which is down here. And so if this transistor fails, you can check this. As long as it's in circuit, it doesn't really make sense because you get this drive transformer that feeds the input of that. So you don't have to desolder it. But if the first place to check is to see if this transistor is shorted out. That usually means that something catastrophic has happened. Maybe the transistor just failed itself. Something could have drawn too much current. On the Electro Home G07 arcade monitor, a really common failure is the flyback fails, will crack even, draws too much current, it kills the horizontal output transistor, and it blows the B+ fuse. And that's the situation where the filter cap on that chassis stays very charged. Because it was working, all of a sudden there's no B+, because the B+ fuse blows because that transistor shorts, and now that cap can't discharge because it's not connected to anything anymore. So you plug it in, it doesn't work, you go, oh, it doesn't work, I didn't get any high voltage, I just take this apart, and well, that cap is still fully charged.
And B+, that's like the main operating
Oh yeah,
voltage
I should have,
for it.
I meant to go over that. B+ is what is it's the main operating voltage of the chassis, or the set. In like a terminal monitor, or like a monitor at a K-Pro, that B+ is actually just 12 volts. In most TVs and arcade monitors, it's rectified line voltage plus or minus something. So it's usually like 120 volts or 110 volts or 100, something around there. There's going to be a regulator for that voltage. It's rectified and regulated because if that voltage like wavers, you'll start getting noise in the picture. Like you get a hum bar if that isn't regulated properly. If you have a TV where the picture is kind of like shrinking and growing and kind of like it's okay, but it's like the picture isn't stable, or you get this rolling bar on the screen. That can either be that the primary filter capacitor is bad or the voltage regulator is bad. And there will be a test point for the voltage regulator on something like this. It's going to be usually one of the ends of these resistors. Sometimes it'll be marked. Sometimes you just kind of have to figure it out, see if you're getting a stable something there. Other times it'll be like a spec for it, especially like this monitor. It's what 100 and I want to say it's 102 or 108. 108 sounds right for a Sanyo, but don't quote me, I don't remember. But this one has an adjustable regulator that has a pop to adjust the voltage. Most TVs like that are going to have a fixed regulator chip that just does one thing. It'll say usually it's like an STR. It's this one here. What does this say? STR, yeah, here. STR 3130 is a really common regulator. It's 130 volt fixed regulator for the B+. So if you measure the B+ in this TV and you're getting something other than 130 volts, there's something wrong with this chip. Usually when this fails, it won't stay, it'll kind of waver around. Line voltage fluctuations will affect the TV. That's why really old TVs, somebody with somebody trying to vacuum cleaner, the picture kind of shrank because they didn't have a solid state regulator like this. So anyway, the fact that some monitors don't have a local oscillator is something to remember that is a thing. So if you've got something like say a K-Pro where you're not getting any high voltage, the picture doesn't do anything. It might not be the monitor. It might be the fact that the computer isn't working or the computer's power supply is, maybe the 5 volts is gone. monitor doesn't need 5 volts, but the logic does. And without the logic, the monitor's not increasing the voltage. And another incredibly common, I don't know how much time, I think I'm almost out of time, but one really common failure I want to go over. This is the DEC VT100. This is the monitor inside the VT100. Incidentally, so if you don't have the schematic for a given monitor, especially if it's like a 12-volt monitor that's in a terminal, you can kind of reference something like the VT100 monitor schematic because, again, there's only so many ways to build a little monochrome monitor. They're very simple. None of the component values align, but at least you get the basic roadmap of kind of how the parts fit together, so you can trace your own port out. But in this case, this is the horizontal. This is the width coil, horizontal linearity coil. This is the horizontal yoke. So you can kind of just follow this whole circuit back. And there's the flyback primary. Or no, wait, that's the, where did it go? It's 7 to, there's primary. Here's the flyback primary. That's right. Mid coil, horizontal linearity coil, yoke. This part right here, this is a 10 microfarad bipolar electrolytic capacitor. These fail with huge regularity. In fact, this monitor here is this was working. Where I was testing something for one of the exhibits. This monitor was working, and then it died with a and the picture went away. I haven't had time to actually fix this, but I brought it to take apart to show you kind of how a monitor fits together. But I can almost bet, in fact, I have the parts, I'm going to change it, I'm going to see if it fixes it. I can almost bet that that capacitor in that circuit has failed. Again, it's in series, you can always find it, so this monitor, this is an MDA monitor, it isn't the same monitor that's there. But I can look at it, and I can say, okay, there's the flyback, there's the horizontal output transistor, there's the horizontal yoke, oh look, there's that capacitor. And here's the horizontal, this is the width coil, linearity coil, and there's that capacitor. In this case, this one is a 4.7 microfarad 25 volt. It's a bipolar electrolytic. It doesn't have the negative marking on it. These capacitors, they don't age well. They've got in this case, 18 kilohertz on it the whole time it's in operation. They break down. They fail. And when they do fail, you'll either lose the horizontal, as is the case of the compact Macintosh computer. There's one of these in the top corner of the analog board on a compact Mac. And when that fails, you either lose the picture entirely, or a lot of times you lose the horizontal. You just get this vertical line. I've heard it called vertical line disease on Macs. But that's that capacitor. When replacing them, do not get electrolytics. Get a film cap. You can now get like a 10 microfarad film cap, like from Lima or one of those. Yeah, okay, it's like a $2 or $3 capacitor, but it'll last forever. They don't make high-frequency bipolar electrolytics anymore, and even the whole principle behind bipolar electrolytics is stupid, so kids don't buy it. Get a film cap to replace that. The value isn't super critical. Like in this case, okay, that says 10, but I could put a 6.8 in there and it'll work just fine. You can pick nits that, yeah, the linearity might not be quite exact, but close enough is close enough. It'll work. Obviously, as close as you can get to the original value is nice. But something to remember, if you're working on anything that's a monochrome monitor that has a circuit like this, like a compact Mac, most MDA monitors, most terminal monitors, if it's completely dead, check that cap first. That's just kind of a good starting point. A little bit more time. Is there any specific questions?
Yeah, I have a very similar ADM3 with my Cataract on the back.
Oh yes, cataracts. Yes.
Should I touch that or what?
I've done it a whole bunch of times.
But what is?
If people don't know what cataracts is, you look at the screen. It looks like it's got mold growing inside it. Some picture tubes used to have a second safety glass layer laminated over the top of the first one, or over the top of the tube. And there's this PVA compound, this glue that was filled in between the layers, and that glue starts to break down. In the case of the ADM3A, if you've got one starting to get cataracts, it's
Got a lot of cataracts.
Yeah, you have to be careful with that because that glue leaks out of the bottom of the tube and down into the electronics, and it'll destroy the keyboard contact. It's actually really corrosive.
Okay.
Now there's two tubes several tubes are using ADM3As. They've made these things for a decade. Some of them will have this. So if you look at the tube or the edge, and there's like this metal. The face of it looks like it's this metal stamp thing, like encases the whole front of the tube that fits all around. Those are really bad to get apart. Like they're epoxied in from the edges. Regular ones is just that glass is glued to the front of it and it's sealed with tape on the outside. Those you can. What I do is I'll take the tube out of the terminal, put it face up, like neck down in like a plastic trash can, and put on safety face mask, wear gloves, long sleeves. I use a heat gun and heat the face of the tube up a lot until that compound starts to soften. And then I'll use something like a shard of wood or like a piece of cut a piece of wood or a chopstick, something, kind of poke at it from the edges until you start to get air bubbles to kind of form underneath that glass. The more corrode, the more cataracted it is, the more moldy it looks, the easier it is to get apart. It'll start to smell real bad too. And once it starts to let that go, you very gently kind of apply a little bit of pressure and separate the glass from the tube. It's easier to do on a small tube. The big color TVs from the 1960s are very nerve-wracking to do because you've got this huge vacuum.
So what's the danger factor other than, I mean, is it going to implode or?
It would implode. So if you do something, well, the easiest thing to do is to break that faceplate as you're taking it off. If you pry too hard, like don't ever pry on it. You've got to be very gentle. Let it kind of come apart.
Okay.
You could break the faceplate. That's one thing. That's not really the end of the world. The danger factor comes in if you heat the tube unevenly, if you ding it or something, it's possible for the tube to implode. It could do so violently. So who here has dropped a monitor and heard that hiss noise? Yeah. Or just throwing away a junk tube or something. If you break the neck of the picture tube, it'll just kind of shatter and hiss, and it really doesn't do much. If you break the face of the tube and it's still under vacuum, you could get a lot of.
So it's gonna fly out this way.
It should go in, but it might bounce back. So, like, if you're ever doing Cataract's work on a tube, wear a face mask. Or wear long
Use
sleeves.
like a welding mask or what?
I just use like a grinding mask, like one of those, just a plastic face shield. You're just trying to keep flying glass out of your eyes. Safety goggles are probably good enough too, but I like to protect my whole face.
Okay.
I've never imploded one. I've never blown one up like that.
So your heat gun, you're going like this, like a spray paint
You're
motion?
trying to get it as even as possible. Like go slow, heat it up, because you don't want to create this huge thermal differential where one side of the tube is way hotter than the other, and you just crack.
What about, I heard guys like on YouTube, I've done a few, look on YouTube, they let the sun beat on it.
If you live someplace that has sun, that would work. But you still need the heat gun, or would usually need the heat gun to finish it. But I live in Albany. There's not enough sun to.
I'm in Michigan, so
yeah.
same.
There's not enough sun to do that with. If you lived in California or Florida or something, or Texas, or something, you could probably just put it out there and bake it off in an hour. But you know.
So basically, heat it evenly, and then use
something wood, something wooden or hard plastic.
What, like a spatula?
Yeah.
You want to keep like just a little bit of constant pressure on it so it will lift.
So
you have to be patient.
You don't be impatient. Don't pry on it. Don't force it. You can crack that. You can break that glass.
Okay.
And then once it's apart, you can scrape that goo out of the tube or off the top of the tube, and then let it all cool down before you try and use any solvents to clean it off.
Now what about putting it back all together?
I put strips of that foam mounting tape around the outside edge, and then stick the faceplate back on, and then fill the edges either with like silicone caulk works real well. I use RTD in the pinch, or sometimes even just masking tape or painter's tape, or not painter's tape, packing tape. That's what word I'm looking for. You want to keep dust out of there. You got to make sure there's no dust trapped between the faceplate and the tube. Okay. And you want to keep the dust out of there because, as you've noticed, high voltage attracts this black gook, and you will get dust sucked down in there if you don't seal it.
Okay. Thank you very much for that.
You're welcome.
Suppose you pick up like an old double video 80 by 24 ads or whatever on the front terminal, and it's been well used, and adjusting contrast and brightness.
It's kind of a relative term at that point.
Right.
So
are there ways of dealing with that?
Kind of. So that what you're talking about is a tube that's worn out. It's low emissions. that's one thing I didn't get to. Is so you've got the filament heating the cathode. The cathode is emitting electrons, but as time wears on and that gets used more and more, it doesn't emit as many electrons. It starts weakening. The cathode material starts getting worn away and kind of used up. So there actually are devices like this. This is a CRT Rejuvenator. What this does is, besides being a place to accumulate crumbly foam particles from this stupid thing, I can connect this to a picture tube. One that's not powered, obviously. It's be powered from this, and this will tell me what the emissions are like how many, how good that cathode still is, what the emissive properties are, and then I can apply a high voltage kind of a pulse to try to burn off the coating, the used up coating, and hopefully expose more material. Because as it ages, it starts to kind of widen and get fuzzier and fuzzier. And this can, if you burn off the coating and expose a fresh surface, it can be sharper point again. The danger though is that it can burn off all of it and completely destroy the tube. You can, when you do that, you also run the filament kind of hot. You could burn out the filament. This is kind of okay, this tube is really hard to use anyway. I'm going to zap it and see if I can improve it. You don't really want to do this unless it really is kind of weak. The other thing you can do is simply replace the picture tube, which is easier than you think.
Especially on mono stuff.
On monochrome stuff, it's incredibly compatible. So like that terminal which you speak, I can take this picture tube out of this MDA monitor and drop it right in there and work. All you have to do is take the yoke off, keep the yoke from your terminal, swap just the glass tube, and put it all back together. There's no convergence. I didn't get to convergence. There's no convergence with monochrome.
You can do that. I can.
No, it's
really easy.
It's really easy.
So these, on the neck of a tube, a color tube, on the neck of the color tube, you see these rings. There's 3 pairs of them. 2 of these are for purity. That adjusts to make sure all the red only hits red, all the green only hits green. So if you have, that's why the tester, like this tester, I can sort of solid, if I try to the right channel. So I can put a solid green screen here. And this is another one, as I mess with the early magnetism, see the purity goes all out of whack. Those magnets need to be aligned to ensure that hits on the right. So the aligning a color tube is actually kind of a lot of work. It's very tedious. You set the purity first, and then you also adjust the position, relative position of the beams. So you get like see like the white line that's fringed like red on one side and blue on the other. It doesn't actually line up. Monochrome has no such convergence because it's only one gun. If you ever have a picture that's tilted, that's the yoke is just tilted on the neck of the tube. It's not straight, so you can just turn it straight. There are all these little magnets on the edges of the yoke that can be rotated to adjust geometry, like the bow in and out of the corners. Then there are 2 rings on a monochrome tube. All these do is adjust position on the screen where the picture is. So if the picture is like off to one side, too high, too low, there's no electronic controls. It's done with those magnets. But again, there's no convergence. It's literally just plug it in, slide it on, adjust the yoke so it's straight. It takes about 5 minutes.
Yeah. Whereas, like, if you, say you had a color tube, and you're like, oh, the picture's a little crooked, so I'm just going to rotate the yoke.
Now you've
thrown out the convergence, and you need to spend an hour, because every adjustment affects every other adjustment.
Yep, they're all interacting with each other.
Yeah.
Whereas a monochrome tube, it's just the one thing. It's really simple. If the picture's crooked, and you do that while it's on. Like you loosen this ahead of time, and then you just, as long as you're not touching the coils of the yoke or any, don't ever touch these electrical contacts on the yoke while it sets on. You will very much that will burn through your fingernail actually.
Yeah.
I would wear 3 pairs of rubber gloves.
Yeah, I never wear rubber gloves. Then again, I've done this a lot. I have no
it makes you more clumsy.
Yeah, it makes it clumsy, the gloves and other things.
Yeah.
Any other questions? I know I missed a lot of things. Yes.
Yeah. So I'm kind of making a home room computer,
Mhm.
and it has really like it has a text display output that's monochrome.
Yep.
And I'm trying to make a color expansion card with the TMS911A video chip.
Okay.
And if I try to display color on the screen, it shows all these vertical black and white bars.
Because you're displaying it on a color set or a monochrome set?
I'm actually displaying it on like a modern TV, but
Oh, because if it's a modern TV, it might not be interpreting the signal properly. The NTSC signal is kind of weird, so you've got this like phase differential for the modulation of the color. The Apple II exploited this, which is why if you display color Apple II games on a monochrome screen, they look like crap because you've got these like vertical bars that don't quite line up because it's
The spacing between the bars
isn't even.
And the TV like misinterprets the spacing as
the
color
signal.
information.
Yeah. So it could be that the frequency is just a little bit too far off for your modern TV to understand.
yeah, I looked at an oscilloscope and it looks high.
It could be a DC offset too. Do you have a blocking capacitor in there?
Yeah, I looked it up and I found out that DC offset would help, and I haven't figured out how to implement DC offset.
You can do that with a resistor divider to get the voltage, and then a capacitor to isolate the signal from the rest of the circuit, so you're only applying the DC to the after the capacitor. Or you can block the DC. You shouldn't have a DC offset on a composite video signal. Like, it should be not have that. So you'd want a capacitor instead a blocking capacitor for that. The Super Nintendo, for instance, outputs a DC offset on its RGB lines. If you just connect that straight up to a monitor, it will make the most terrible picture because the monitor is interpreting the DC offset improperly. So the official Super Nintendo RGB cable for the American market has capacitors in the cable to block the DC on each of the 3 RGB lines.
Okay, so I was gonna say that I actually have for the monochrome text output, like a terminal, it's actually 2 Arduino chips, and it looks very clean on the oscilloscope, and it's like aligned at 0 volts, but the other one is higher, and it's like also like.
Okay, so you've got a DC offset on your color information, and it doesn't line up with the monochrome information.
Yeah, like the vertical pulse that goes down doesn't go all the way to 0 volts. It goes like to 1 volt.
Yeah, so yeah, I would put a DC blocking capacitor in your color output to see if you could get it to kind of, because it should be the vertical pulse, the pulse should be blacker than black. It should be driven below 0.
Like I try to display color like yellow, and it's like black and white lines.
Yeah, I mean you start getting that's an NTSC decoding kind of an issue. What kind of TV are you using?
It's this little tiny little like flat TV.
I would try with a CRT just to kind of see, because any of the flat TVs have to interpret a analog NTSC signal electronically, and tricks that display color on CRTs don't necessarily work. That's why the Apple II's video output doesn't work very well on a lot of modern TVs. It'll either be black and white or incredibly terrible because it isn't interpreting that.
Isn't the Apple II's color signal artifact color?
Yeah, that's what we're talking about, where it's creating these pulses of, it's black and white signal with pulses that are timed just right to be kind of NTSC, or kind of color. And the TV interprets it as color, but some modern TVs don't interpret it correctly. It's designed to work with a CRT specifically.
So if I were to, I've tried a circuit that has like a capacitor that one side protects the ground, and a resistor that also one side protects the ground, and the capacitors, one side of the capacitors is the
You can come to me later and show me the circuit and I can help you with it.
yeah.
I kind of have to see it.
Yeah.
So if I were to get a CRT, where can I get it?
What'd you say?
If I were to get a CRT, where would I get it?
I don't know, go out on crash night and find the TV.
Like, go
Thanks,
to your,
guys.
go to your local dump, and they'll have, because CRTs are hazmat, right? So they have like
If
separate.
they're paying to get rid of them,
Yeah.
so a lot of places will be happy to either give them to you or sell them to you for a couple bucks.
Yeah.
So,
So, Ian, earlier when the gentleman was talking about how, like the contrast and brightness don't work well on my high-hour monitor. I had one and I asked you about it.
Yeah, and that's what I was telling you, if you make this a little closer together, where
Yeah.
so we don't have that
Well,
peak anymore.
Remember that the Motorola monitor that I gave you a while back, where
Yeah.
like you turn the brightness up and like the picture would invert.
It goes negative because you're actually driving the gun past the
Yeah.
cutoff point.
And I was like, why is that? How could that be? And you described it perfectly. It's like if you've ever had like a stereo system, like an audio amplifier, and you just turn the volume up to the point that it's just all distorted and crazy. It's the same thing in the monitor.
Yeah, it's like clipping of the tube itself.
Yeah.
You're driving the tube in a cutoff, and it's clipping. This is how a vacuum tube would clip,
Yep.
which would be distortion in a tube amplifier. Just messed up picture on TV. So yeah, a really worn out tube. That's another good, like a good set of a really worn out tube. You get this like negative effect on the colors when you turn it all the way up.
so,
Yeah, actually, if anyone wants to see that, the tube in my NCR in the PCs exhibit is super shot. So if you crank the brightness all the way up, the light gray and dark gray will invert.
Yeah, and that tube was like, I didn't even register on the tester before I zapped it.
And it like made it like the needle just bare. I'm amazed it makes a picture at all.
I know. I kind of want to don't.
Yeah.
I think we're out of time, but any quick questions?
yeah, I have a Nintendo, like a Super Nintendo,
Original Nintendo?
system. And I plugged into the same monitor and it works fine.
Oh, because the NES puts out like a nice, clean, properly formatted NTSC signal. Like it's actually got a PPU and all that stuff to create a really nice signal. It's not.
It's not artifact color.
Yeah. And I have to look. I have to see your construction circuit to see what's going on.
Yeah.
Maybe the voltage levels are wrong. But like I said, we can talk later. Yes.
I have this old Philips RGB monitor. I use it for my Commodore 128. So when it's cold, the picture is shifted vertically down. Later it will go up by itself, or sometimes I have to give it a little tap. Is that the thing you talked about earlier about the...
Crack solder joints on
Yeah.
there probably, especially if you can hit it and it pops up.
Yeah.
Look
But
around the
when
vertical.
it's cold, it doesn't do that. But when it's warmer, then I can
Yeah,
tap it and it will go.
Yeah, because the heating and cooling, the heat kind of expands things and it starts to either disconnect or disconnect that
So I
joint.
should open and check for it.
Yeah, and look for cracked solder joints. You ever seen a cracked solder joint? You see like a pin with like a ring around it where the pad is. And you look around the vertical chip. It should be fairly easy to find. And around where the vertical, you can follow the vertical hole for size controls back and check. You've got a cold solder joint somewhere. It's probably on the chip because it's it's on the heat sink and it's soldered to the board, so it can't really move. But then it's trying to.
Thank you.
I think we're encroaching on somebody else's talk at this point. So yeah, hopefully I